What do you see? Special glasses let colorblind people see the world like never before. About 10 years ago, glass scientist John McPherson was playing in an ultimate frisbee tournament in California. At the time, McPherson specialized in making glasses to protect surgeons' eyes from lasers that they used to perform operations. Some of the doctors reported an unexpected effect of the safety glasses. The lenses seemed to make certain colors, like the deep red hue of blood, more vivid. A few surgeons even enjoy wearing them outdoors as sunglasses. McPherson was wearing a pair at the frisbee tournament when a teammate asked to borrow them. The friend put the glasses on and looked out at the field, scanning the end zone marked with bright orange cones. Dude, he explained. Suddenly, I can see the cones. At first, McPherson didn't understand what his teammate was talking about. The friend, a talented player, explained that he was colorblind. He'd always had trouble distinguishing the orange cones from the green grass surrounding them until he put on McPherson's glasses and the colors popped like never before. A diagram of the human eye, showing point of focus relative to rods and cones. Lens, iris, rods, cones, optic nerve. Illustrations by P. Clay Sherrod. Color blindness 101. Color blindness can refer to a variety of color vision deficiencies ranging from difficulty in distinguishing certain colors to complete absence of color vision, which is very rare. Around 50 million Americans, more than 4% of the population, have some form of color blindness, which involves trouble telling apart colors containing red, yellow, or green. Most types of color blindness don't affect visual acuity, the sharpness of vision. Color blindness is usually inherited. It's caused by problems with light detecting cells in the eye called cones. The eye normally has three types of cones, each containing a different light sensitive molecule called a pigment. Each pigment is not most sensitive to a different wavelength of light. Wavelength is a distance between the peaks of a wave of light energy. Wavelength is related to light's color, but most light is a mix of wavelengths. When light hits the back of the eye, the brain rapidly combines and interprets signals from the cones to create the perception of color. If any of the three cone pigments is missing or abnormal, a person will have some form of color blindness. The genes for two of the pigments are located on the X chromosome, which plays a role in determining a person's sex. Typically, men have one X chromosome in each of their cells, and women have two. If one of the cone pigment genes on a man's X chromosome is abnormal, he'll be colorblind. The abnormal gene is the only copy he has. A woman may have an abnormal gene on the X chromosome, but as long as she has a normal version of the gene on the other one, she'll have full color vision. As a result, color blindness is far more common in men than in women. Seeing differently. Colorblind people do just fine most of the time, but can run into problems in certain situations. Some may have trouble telling whether produce is ripe, seeing whether meat is properly cooked, and noticing skin rashes or sunburn. They also may be unable to distinguish the colors of traffic lights. In daylight, they can often tell the lights apart by their positions on the traffic signal, but at night it may be impossible to see. In schools, students sometimes have difficulties since a lot of information on assignments may be color-coded, says McPherson. The issue may even come up on the tests. Teachers may not realize that certain students are colorblind, and students themselves may not know if they haven't been tested. Currently, most states don't require color vision testing in schools. On the other hand, colorblindness may have some upsides. Research suggests that colorblind people can distinguish certain colors that look identical to a viewer with standard color vision. And some types of colorblindness may give people an advantage at detecting camouflage. During World War II, colorblind servicemen reportedly spotted hidden enemy soldiers, ships, and weaponry that others couldn't see. How the glasses work. After McPherson saw his frisbee teammates' reaction, he decided to focus on creating lenses for colorblind people. His glasses can compensate for certain types of red-green color blindness by filtering out yellow light. Yellow falls between red and green on the electromagnetic spectrum, which includes all types of light arranged by wavelength. Blocking some of the yellow light helps to more clearly separate the red and green light that it hits the cones in the eye. That can help the wearer distinguish red from green when the signals from the cones are combined in the brain. Color perception isn't a simple reflex, says Bevel Conway, a neuroscientist at Wellesley College in Massachusetts who studies visual perception. It depends on heavy computation that the brain performs on the information it gets from the eye. Restoring the rainbow. McPherson conducted experiments to find out how well the glasses worked. Some people with red-green color blindness become much better at identifying colors with glasses on, and some improve their performance on certain tests of color vision. The glasses don't work for everyone. People who have abnormal pigment may notice a big difference in the color vision, but people who are missing a pigment usually don't see much improvement. McPherson co-founded a company, Enchroma, that sells the glasses. Anyone can take a test at the company website to see how likely it is that the glasses will help. Some researchers hope to develop a permanent cure for color blindness. In 2009, University of Washington scientist Jay Nates injected a pigment gene into the eyes of 2 colorblind adult monkeys. Soon, the monkeys started passing tests of color vision that they had consistently failed before. Someday, a gene-based fix could open people's eyes to a colorful new world. Number 6. Which details will be most important to include in a summary of the text? Choose 2. A. McPherson's glasses are able to help some colorblind people because they filter out yellow light. B. As long as a woman has at least one normal version of the gene, she will not be colorblind. C. Some colorblind people may have trouble seeing whether meat is cooked enough or noticing skin rashes. D. Each eye has 3 types of cones that contain light-sensitive molecules. E. Colorblindness is a condition that is usually inherited and prevents people from seeing some or rarely all colors. Number 7. Which detail best supports the idea that colorblind people are minimally impacted by their color blindness most of the time? A. Students sometimes have difficulties since a lot of information on assignments may be color-coded. B. But at night, it may be impossible to see. C. During World War II, colorblind servicemen reportedly spotted hidden enemy soldiers, ships, and weaponry that others couldn't see. D. Most types of color blindness don't affect visual acuity, the sharpness of vision. Number 8. How does the image help the reader understand the passage? Select 2 reasons. A. It explains why only 4% of the population has a form of color blindness. B. It explains how the cones contain pigments which are sensitive to different wavelengths of light. C. It demonstrates how any pigment abnormalities can result in a form of color blindness. D. It illustrates the parts of the eye, some of which work together in order to see color. E. It provides a visual for the parts of the eye that are referenced throughout the passage. Number 9. The author states that more than 4% of the population has some form of color blindness. About how many people in America has color blindness? A. Around 5 million Americans. B. Around 50 million Americans. C. Around 500 million Americans. D. Around 15 million Americans. Number 10. Read the paragraph. When light hits the back of the eye, the brain rapidly combines and interprets signals from the cones to create the perception of color. If any of the 3 cone pigments is missing or abnormal, a person will have some form of color blindness. What does the author most likely mean by the phrase the perception of color? A. The amount of color. B. The texture of color. C. A person's view of color. D. A sudden change in color.